right. Bob Cooper was born in 1900. By 1930, he had 3 sons. So, how many sons did he had in 1900? No. In 1900, he was born and he already had 3 kids. Really? Okay. We don't think before we speak. All right. By 1930, he had 3 sons. All of the Coopers, all with the Cooper's last name. By 1960, each of Bob's 3 sons had exactly 3 sons of their own. There you go. So it would be what? How many sons? 9. 9. Because each one of these has 3. Okay? All right. By the end of each 30-year time period, the pattern of each Cooper boy having exactly 3 sons of their own continued. How many Cooper sons were born in the 30-year period between 1960 and 1990? All right. So how many sons were born between the 1960 and the 1990? 20 what? 27. Very good. All right. So, so in reality, um, do I need this 1900 and the 0? No, I don't. No, I don't. I just wanted you to understand the difference between being born and after 30 years I have 3 sons, right? So, is it an arithmetic or a geometric sequence? Again, you're multiplying by 3, but then you tell me that it's arithmetic. And it's because not because we don't know, but because we don't think before we open our mouth because it's a race. We got to be the first one. So I'm going to ask again, is it arithmetic or is it geometric? It's geometric. Very good. Now let's come up with the general rule. All right? So what's my rule? A of whatever it is that I'm doing. We're going to calculate 1 in a second. A of n equals what? Let me write this first one. N minus 1. All right. So what's my A1? 3. And what's my ratio? My common ratio? Because you're multiplying by 3. Very good. So what I want to know is, what would it be A of 5? That's what I want to know. All right, so how do we do this? Okay, can we go to start on a geometric sequence? Please, guys. That doesn't look like stats. So why are you telling me stats? This is why I get frustrated. How do I do this? Okay, A of 5 equals. Let's start plugging in. To the power of 4. All right, so let's do that. Two hundred and what? 243 kids. Now, what year would that be? So there would be a total of 243 sons born by this time, right? Now, I want to know the year now. I want to know the year. At what year where they have already lived 243 Coopers? All right, I'm not going to tell you, so think about it, because I'm done thinking for you. I do too much thinking with B3. Chris, you may want to pay attention. 1981? Really? By 1990, there were already 27. So why are you telling me 1981? By 1990, there were already 27. So there's no way that by 1981, there was 243. No way. Let's think about it before we speak. Let's think about, does it make sense? All right, so let's see. This will be your first term, right? This will be your second term, and that will be your third term. I need my fifth term, right? So my fourth term would be what year? 2020. Very good. But that's not the term that I want. I want the fifth term. So the next one would be, I'm going to write it, I'm sorry, 2020, that's what you guys told me? Yes, and the next term is 30 more years, so it would be what? 2050. Very good. So by year 2050, there would have already been 243 sons that have the same last name, Cooper, right? All right, this is not hard. We just don't think about things. All right, are we next one? We're not going to find the 100. We're going to find the 10th term, okay, because 100 is too big. All right, so we got to figure out what kind of sequence it is. All right, so let's see. 1 and how many? 1. Okay, I'm not asking the factor. I'm asking how many. Can we please listen? 6, 12, and then 24. After you count, then you can decide if it's an arithmetic or a geometric sequence. And it's obviously a what? Geometric sequence. Very good. It's obviously geometric. So what's my A1? It's 6. What's my denominator, my common factor, or my common ratio, right? It would be 2. All right, so I want the 10th term. That would be A of what? Okay. I'm tuning out because I'm going to go insane over here. Come on, kids. We can do this. So this would be A of 10 equals, this is my formula right here. That's my formula right there at the top. I highlighted it so you could see it, because I don't want to keep writing it over and over again. A of 1 would be 6. The common ratio would be 2. And then to the power of 9. 10 minus 1, which is 9. And now the calculator can take over, right? Well, yeah, we can do that really quick because the calculator does it, right? So we need to learn how to think. Because giving me that answer that quick doesn't impress me one bit because the calculator does it, not you. Correct? So the 10th term will have 3,072 plus signs, right? Because they're little plus signs. Yay? All right. So this one is really easy. On this 4, we got to find the missing values for each arithmetic or geometric sequence. Then we got to answer some questions about it, okay? So look at this one. 5, 10, 15. That will be a 20. Very good. Is it a constant difference or is it a constant rate? Are you multiplying by 5? So you're adding 5. So is it a constant rate or is it a constant difference? It's a constant difference. You're adding 5. Correct? So the difference is 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. So this is not a constant rate because you're not multiplying. You're adding 5. Do we understand that? So it's a constant difference. And what is the value of that constant difference? 5. All right. What are my numbers? 20, 10, 5, 2.5, 1.25. Thank you, Christian. All right. Is this a constant difference or is this a constant rate? Rate. Thank you very much. You're not adding. You're not adding or you're not subtracting the same number to get to 20 to 10 to 5 to 2.5 to 1.25. So this is a constant rate. Now be careful. What is the value of that rate? It's not 2 because 20 times 2 is not 10. See? We can think about, okay, so 20 times negative 2 is negative 10. Say that again, Evelyn. Thank you very much. 100 points for your family. It's 0.5. Because it's half of what it used to be. So it's 1/2. We got to be able to think. That's the problem with my class. I ask you to think all the darn time, which is, I don't think it's a problem because it gets you ready for high school. All right. 2, 5, 8, 11, 17. All right. Think about what you did to get those numbers. Is it a constant difference or is it a constant rate? It's a difference because what are you adding? 3. Thank you. Okay? All right, next one. 30, 24. What did you say? 18. Very good. 12 and 6, right? Think about what you did to those numbers. Is it a constant difference or is it a constant rate? So you're multiplying? 30 times what gives you 24? Oh my God, if you do it, Nobel Prize for you. Come on. It's not a rate. You're taking away how many? 6. So it's not a rate. Do we understand the difference between a difference and a rate? A rate is per unit. You multiply. That's what I did to figure out that I needed more than 80 cookies to bring today so that each one of you could have one. I multiplied a cookie by all the kits that I have, correct? That's a rate. This is not a rate. You're not multiplying anything. Be careful. What's the value? So 30 plus 6 is 24. There we go. There we go. Because 6 will be a choice on Friday. 6 will be a choice, and that's not the right one. It's negative 6, not positive 6. All right, let's go to the next one. This one right here. This one should be done like in a hot minute. So you got to match that with one of these. What would you match the first one with? Which one? Who said it? Thank you, Evelyn. You're on fire. Tell me why is it D? And that's the only one that has a negative 3. Thank you so much. She's just looking at her first term. That right there. Commended right there. This is, for those of you that are really good with A, B, C, D, this is the way to do it. I'm not working out anything. All I'm doing is, it's a match. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It has to have one exact correct answer. She knows that that first number is your first term. There's only one that has a negative 3. Very good. 100 more points for your family. So the correct answer is D over there. Good job, Evelyn. All right. What about the next one? We already have D. Which one, what? E. Because the first term is negative 6. And then I figure out, this is what I do. I double check with the 6 times 3, 18, right? I double check with the rate, with the constant rate, with the common ratio. All right, what about the next one, number 3? F. Pretty easy to do. There's your negative 4. You can't see it. There's your negative 4. There's your negative 4, your A1. All right, what about the next one? Most definitely C. Look at your A1 is negative 7. Negative 2. So that will be A. And then by process of elimination, the last one needs to be B. Yay? Alrighty. So that one is pretty easy to do. I told you it was going to take a hot minute, and that was it, right? Are we good? All right. Let's go to the paper that I just gave you. All right. So, for each arithmetic sequence, determine the values of A and D, and I'm going to tell you what A and D are in a second. Then write the next 4 terms, okay? So, and this is going to be in your cheat sheet. For arithmetic, I told you that you just go straight to stat, right? But there's actually a formula, okay? I just don't need you to learn the formula because you can go straight to stat, right? But what happens if it asking you for the D or the N or the A, right? So this is what we're going to use. So we're going to go ahead and copy that over here at the top. A of N. This is only for arithmetic, right? Because we already know geometric. A of N equals DN plus A of 0. Now, this looks a lot like y equals mx plus b. That's why we can go to stat, right? That would be your slope. I'm going to write it. Hold on. Right? That will be your slope. So D is your slope, which is the common difference. Yes? And then A of 0 would be what? And that makes sense because it's your first term, right? Well, not your first one, but when x equals what? 0, right? Your y, on your y-intercept, x equals 0. Yay? Does that make sense? Yes? Now, you can also see it this way, so let's write the second one as well. A of n equals d, n minus 1. Now, this one is when you don't have a of 0, when you have a of 1. If you don't have a of 0, then you need to do a of 1. Yay? And this will be on your cheat sheet along with the other one, so you don't need to worry about that, learning that. But we're going to have it right here for us to, maybe I should have it over here ready for us. All right, for each arithmetic sequence, determine the values of A and D. So how do you think we need to do this? It's arithmetic, right? All right. So what would that give me? The next what? Okay, I need the formula. I need A and I need D. I need A and I need D. What is D? D is 3 because that's the constant rate of change, right? And that's my slope. Yes? So D is 3. But I need A, which is A of 0. So are you telling me that this is A of 1? A of 0 should be what? Very good. How do you know? Thank you. If you're adding, give your family 100 points, Orlando. If you're adding 3 to this side to get A of 0, all you need to do is take away 3. Does that make sense? Because this is not A of 0. This is your first term, and that's your second term, and this is your third term. And if you want to go to stat, you can. Let's go to stat. You are going to go to stat. I'm not going to. First term is 12. Second term is 15. And third term would be 18. So go to stat and tell me what you get. You should get y equals 3x plus 9. Yes? We got it? All right, so now we need the next four terms. Put it on the table and give me, or just keep adding threes. The next four terms. 21, 27, and 30. There you go. Yay? All right. These are all arithmetic. It's telling you that they're arithmetic. All right? It's telling you that they're arithmetic. All right, what's D? Very good. You're adding half. All right, so what will be your A of 0? Very good. 0. Good job. So that's my equation. Y equals what? And that's it, because my y-intercept is what? 0. Do you see it? Yes? All right, so what's my next term? 3 halves plus 1 half, right? Or you can just go straight to where? I would just go straight to the y equal to, right? I think there's a lot less, oops, sorry. I think there's less plugging in there. Okay, so I have 3 halves. The next one would be 2. See, look at where I'm looking. You see that? I'm looking at the table. Then it would be 5 halves. Then it would be 3. And then it would be 7 halves. Just keep adding. 0.5, right? 50 cents. That's what you're adding. Are you with me? All right, so A and D. Given the values of A and D, write the first 3 terms for the arithmetic sequence. So A is 5, D is 2. So what's the first number is? A of 1 would be 7. Very good. But let's come up with the rule first. What's my rule? You have what you need to write the rule. You have what you need to find the rule. Yes? Mm-hmm. All right, so what's my formula? 5x? Where's your slope? Can we look at it? I wrote it, and I wrote it right underneath it so you could see it. Your slope is not A, it's what? D. Your common difference. That means it's going up twice, right? So 5 plus, that's why Laurenisha said is 7. You need to take that paper home and finish watching the video. All right, so that would be 2x plus what? Plus 5, because this is A of 0. All right, let's do the next 3 terms. A of 1 is 7. A of 2 is 9. And A sub 3 would be 11. There you go. We're done. And you can write it as A 2n plus, maybe we need to start writing it that way because you might not see it y equals mx plus b. But it's the same, right? It's right here. And all of these will be on the cheat sheet. Are we good? All right, so let's do this one. A equals what? A of n equals what? A of n equals what? 1/2 n plus 3/4. So this one is going up by how much? 1/2. So let's do A of 1, A of 2, A of 3. What's A of 1? 3/4. Just put. I would put it on the table. All right. I would put it on y equal 2. And then I would just go straight to the table. And I'm looking at a of 1. What is a of 1? 5/4. What's a of 2? 7/4. And what's a of 3? 9/4. All right? Yay? All right, next one. Given the formula for the general term of an arithmetic sequence, determine t of 12. Oh, this is so easy. We're looking for t of 12. What does that mean? What does that mean? Well, in this case it's not x. What is it? It's it's n. N. There's your n. There's your 12. All right? So 1 minus 4 times 12. Go for it. 47? Negative 47, I'm sorry. Yes or no? Yes. All right, t of 12. 1/2 times 12 plus 3/2. So what's t of 12? Mm-mm. On B. We're on B. Negative 47 was for A. That would be 6 plus 3/2. 15 what? 15/2. All right. So these are some of the questions that I'm going to ask you Friday. Okay? I would highly suggest watching this movie again before Friday. All right, which term of the arithmetic sequence, it's 9, 4, negative 1, has a value of negative 46? Which term? Are you looking for x or y? Are you looking for x? It's asking you when x equals this, what is y, but you don't know the rule, so your first thing that you need to do is come up with the rule. All right, it's an arithmetic, so how much are you, what are you doing? Taking away 5, right? So negative 5. Your slope is negative 5, right? Or you can just go ahead and do what? Go to stat, right? Because that's my term 1, that's my term 2, and that's my term 3. Or if you're going this way, instead of taking away 5, what are you doing? If I want to find 8 of 0, Rolando did it about 2 or 3 problems. Add 5. Thank you, Rolando. He added 5. Very good. To find a of 0. Okay? So a of n equals what? I believe it's negative 5n. There you go. And you got to figure out which term has the value of negative 146. So which term is n? Yes? Because n is your term. Your term. The nth term. We saw that on the video. Yes? Okay. Are we looking for x or are we looking for y? We're looking for x, but I don't have any x's because I stopped writing them with y's and x's, right? Unless you want to write it underneath it with y's and x's. It really doesn't matter to me as long as you get it right. I don't care. Just get it darn right. Where's my pink one? Should be an x, right? The term is this one right here. So when x equals negative, no, when y, sorry, when y equals negative 146, what is x? You can either go to the table or plug it in, right? It really doesn't matter. But if you're going for the table, you're looking for the x, that gives you a negative 146 as a y. So either way, all right? So if you're going over here, which is probably what most of you did, you're looking for when the y equals negative 146, which you have to go down quite a bit. There you go. Or you can go to equation solver, exactly. But if you go to equation solver, then you have to plug in that negative 146. So you can do it this way, and that gives you, I keep putting the wrong letter, that the x equals 32. Or since this is your y, you can say negative 146 equals negative 5x plus 14, and then you can go to equation solver like Evelyn said that you could. Still get the same answer. X equals 32. It just depends on what you feel more comfortable doing. Yay? All right, we'll finish the other ones tomorrow, so let's just go ahead and stop it here. So put that notebook inside your notebook in your folder, okay?